For exercise number 3 in the airflow demonstration unit lab session, we remain here at the pressure regulator test section, and we're this time going to study actual shock loss across the flow restrictions that we're going to put in the frame here. And I should say two things. One is I actually made a mistake in at the very end of the previous exercise when I talked about finding Q. I said Q equals the average velocity divided by the flow area. I should have said Q equals the average velocity times the flow area. Hopefully I've mentioned this in writing to you as well, but I just wanted to clarify that. For this exercise, again, we're going to be studying shock loss, and as we discussed previously, the shock loss factor X is defined as the change in pressure divided by the velocity pressure. So we're going to be measuring both the change in pressure across the flow restrictions that we're going to put in here, and we're also going to be measuring the velocity pressure as we did in the past up at the pitot 2 traverse section. I'm not going to show that, just as I did the last time you've seen that. So very simple for this exercise, same thing. And by the way, I also want to repeat that we will be emailing a filled-in data sheet with all of the data to you. You don't need to try to record anything. You'll get that. It's got the regulator sizes, the centerline velocity pressures, and the delta static pressures. But once again, here's the data sheet for this exercise. And we've got the regulator areas there again. The last time we just wrote these down to keep track of where we were. This time we're actually going to use the areas of the flow regulators in the calculations. I'm going to have to show that in a different video though. I can't really do it sitting here with the blower on. So again, just like the last exercise, we'll record the centerline VPs. I've already done that for the first couple of flow regulator sizes, and we're going to look at delta static P. Now this time delta static P, once again, is across the regulator section. In the last exercise, when we were looking at P equals RQ squared, we were looking at delta pressure for the downstream section. Now we're looking directly at what happens with the flow regulators. So to take the data, again, very easy. I've got no restriction in place here, the blank piece. My centerline velocity pressure was 1.029 inches. Delta static pressure is 0.398 inches. So record that there. Okay. Now I'm going to go ahead and put in the first regulator, 3 3/4 inch size. Okay. Now this time, the pressure drop is happening right here at the regulator station. So as we put in these increasingly smaller regulator sections, our pressure drop is actually going to increase here. Previously, when we did the P equals RQ squared exercise, the delta pressure decreased downstream from the flow restriction. Okay, so we'll go ahead and take this. Now the velocity pressure for the 3 3/4 regulator size was 0.832 inches. And in this case, delta static pressure is 1.157 inches. So again, that's the pressure drop between the upstream side of the regulator and the downstream side of the regulator. Okay, that's 3 3/4. Now we'll put in the 3.5 inch square regulator. And I'm kind of, the way that the manometer is set up is I'm giving it a chance to equilibrate because the reading that it shows is the average of the last 5 readings, so I don't want to start the averaging function too early. So for the 3.5 inch regulator, the centerline velocity pressure was 0.723 inches. And then delta static pressure is 1.547 inches. So that is increasing as we expect with these smaller regulators going in. And then we'll just do one more. So here's the 3 1/4 inch regulator. For the 3 1/4 inch regulator, the centerline velocity pressure up there at the pitot tube traverse station was 0.535 inches of water gauge. And delta static pressure is 1.938 inches of water gauge, okay? So there's the data sheet. So just like the last exercise, it goes pretty quickly. We're just taking the 2 pressure readings. If you guys were doing this as a class, I'd have one group of you up there taking the centerline velocity pressure readings and another group taking these delta static pressure readings. So it goes pretty quickly. Again, in this exercise, we're looking at the shock loss factor X, and X is defined as the delta P, delta static pressure, divided by the velocity pressure. So X is something that you can calculate very easily from the data that you took here. It's simply 1 divided by the other. It would be the right-hand column divided by the middle column, okay? That's your experimentally observed shock loss factor. In a separate video, we're going to go through how you would calculate this based on the flow area sizes. So we've got a constant area duct here, and then when we put in each regulator, we're changing the area there. There are equations for that, and in a separate video, it's rather involved, so it's going to take a separate video to show you how to do those calculations. But I want you to compare the calculated values for the actual observed values.